In this video, we're going to solve quadratic equations that contain complex solutions. So the question is that we want to solve each equation over the set of all possible numbers, which would mean so we want to solve for any real numbers as well as any complex numbers. And really our goal by the end of learning complex numbers would be we could look at any equation, no matter what it is, absolutely any type of equation, and understand how to find all possible solutions or the set of the solutions that over the set of all possible numbers. That's the goal we want to get to by the end of learning complex numbers. So we could look at a logarithmic equation, an exponential equation, and understand all of the possible solutions. Okay. Now, just note though that in this video, we're solving quadratic equations because we couldn't solve a polynomial equation, something like x to the fourth is equal to minus 16. We don't understand how to do this yet. All we've learned so far is the idea of, so here, if we want to solve this, well, like we would normally do, even if there weren't complex solutions, we'd take the principal square root of both sides and we apply the square root property with the plus or minus. So we're left with x is equal to plus or minus. Okay, but we've learned how to simplify this, the principal square root of minus 16. So we can continue to solve this. However, if this was an even root other than 2, we haven't learned that yet. So just want to point that out. Okay, but we do know how to solve this. So we know that we take out an I and we're left with the principal square root of 16. So this is plus or minus 4i. And so, I mean, just when you think about this, the original equation was x squared is equal to minus 16, right? Well, okay, let's plug each of these solutions back into the equation. So 4i squared is what? 16i squared, that's minus 16. What is minus 4i squared? That's going to be 16i squared. There you go. Okay, we start by subtracting 12 from both sides. Now we take the principal square root of both sides, apply the square root property. Okay, now take out an I, and we're left with, so this is 12 is 4 times 3, so it's going to be plus or minus 2i root 3. Okay, so we just proceed like we would normally proceed. We solve this like we learn how to solve any quadratic equation. We bring everything to one side, and well, unless for the previous problems, those were special cases where we just had two terms and we could just put them on both sides of the equality and take the square root of both sides. But in general, the general way to solve any polynomial equation is you bring everything to one side and you factor, or if you can't factor, you apply the quadratic formula. So, okay, 3 times 2 is 6. Let's see if we can factor. 6 times 1, that doesn't subtract to 4. 2 times 3, so no. So we need to use the quadratic formula. So minus b plus or minus b squared minus 4 times a times c all over 2 times a. Okay. So let's see. This is 16 minus 24. Okay. This is, okay, now from here, remember the idea is when you have an expression or an equation or anything in math, and you've got a term with like an I wrapped up in it that you haven't taken the I out yet, then you want to stop everything you're doing and take that I out before like simplifying, applying properties, multiplying this by 1 in the form of something, etc. You don't want to do anything until you don't want to be operating with this at all until you've taken the I out. So let's go ahead and do that. So okay, now we can just go forward like normal because I is like any other number, no problem. So, okay, x is root 8 is to root 2. So, okay. So, okay, we've got, let's see, minus 2/3 plus or minus root 2 over 3i. Okay, and so, just to point this out, an intermediate step, okay, we could have written this as minus 2 plus or minus I root 2 over 3. Okay, after we factor out the 2 and canceled. So for a lot of algebraic equations, we leave a final solution like this. We don't separate it up into 2 fractions. We have one nice, neat fraction right here. Just leave it like that, right? We might leave if we had x plus 3 over x squared, we might, if that was a solution to an equation or something, we might leave it like that instead of separating it out. But when it comes to imaginary numbers, you want to write them, the final answer, you want to put in a form where you can see what the complex numbers are. Here we can clearly see what the 2 complex numbers are that are solutions to this equation. Okay, so let's see. 7 times 2 is 14. You can't factor this, so let's use the quadratic formula. Minus b plus or minus b squared minus 4 times 1 times 14 all over 2a. Okay, 14 times 4. Okay, so x, let's see, 36 minus 56. Okay, so 6 plus or minus. Okay, so let's see, 6 plus or minus I root 20 over 2. So x is equal to 6 plus or minus 4 times 5 is 20. Okay, so we've got 3 plus or minus I root 5. Okay, so let's see. We've got 4x squared minus 4x is equal to minus 7. So 4x squared minus 4x plus 7 is equal to 0. Okay, 7 times 4. Let's see if we can factor this. I mean, we're not going to be able to factor it now that I'm thinking about it, because if we could factor it, we could get real solutions. I mean, we could factor it with like complex factors, but okay, so quadratic formula, minus b plus or minus b squared minus 4 times a times c all over 2 times a. So 7 times 4 is 28. 28 times 4 is 4 times 2 is 8, 9, 10, 11, 112. So 112 minus 16 is going to be, or 16 minus 112 is going to be minus 96. So, okay, x is equal to 4 plus or minus I root 96. Okay, so 96 divided by, let's see, 2 is, okay, 48 divided by 4. All right, so we've got 96. That's 48 times 2. That's 12 times 4 times 2. That's 3 times 4 times 4 times 2. So, okay, we can factor out a 4, or not factor out, but take a 4 out of the root, and we're left with a 6. Okay, so now we see that that's going to result in 1/2 plus or minus root 6 over 2i. So, I mean, you can see that what we want to get used to is, by the end of learning complex numbers, is that it's really, I is like any other number. You don't have to, once you've learned how to solve quadratic equations and work with all the different kinds of equations, I is not that big of a deal. You just have to, the only thing is just have to remember you don't want to operate with something that has an I in it that you haven't taken out yet. You don't want to start doing math stuff. That's it. But other than that, it's just like any other number. It shouldn't really be intimidating at all. And I think what intimidates people is that these textbooks, they stop at, after, like, we're going to get into roots of negative, even roots of negative numbers, but then they stop there and they don't at least teach us the fundamentals of how imaginary numbers relate to logarithms and exponentials. It's like, why not go that extra step to where you can kind of complete the whole picture for us? So I think that's what I want to do. We're not trying to become, again, this channel is not about becoming mathematicians, but I think I gave you the whole picture from everything you're familiar with from algebra. It's not much more. Once we learn roots, then the how roots relate to complex numbers like even roots, then I think we would have to do, like, so I to, like, the 2/3, right? How do you, I mean, that you still think about that this way. So that would be the cube root of -1, which is just -1. So, I mean, there you go. I mean, okay, so we have a sense of how to do rational exponents of I, but what about just any exponent of I? Well, that's going to be a natural extension to what we think about would be like 2 to the pi. So, and then let's see, after that, it's just logarithms and exponentials. I mean, that's it. Those are the only fundamental math operations we learn. So I think it's going to be helpful if you have a sense for how to deal with complex numbers across the board. I think it'll be a lot more intuitive that once we're done learning complex numbers, that you could look at any equation in calculus, whatever, that you're going to be presented with. I mean, unless it gets really some weird equation, but the only equations that you deal with 99% of the time as engineers and just applied math, people that do applied math, is, like powers, roots, radicals, rational exponents, exponentials, and logarithms. So if you understand how to deal with complex numbers across all of those types of equations, you're going to feel a lot more comfortable with them in general. So that's the goal. All right, so x squared plus x, because like we would look at this, the idea is we look at this and we just treat it like we would treat any quadratic equation. Right? That's it. Oh, okay, well, we can't factor it. Let's use the quadratic formula. Minus b plus or minus b squared minus 4 times a times c over 2a, okay? So minus 1 plus or minus 1 minus 4 is minus 3. And before complex numbers, we wouldn't know what to do here. No, now we know what to do. It's not a big deal. Minus 1 plus or minus I root 3 over 2. Okay, so x is equal to minus 1 over 2 plus or minus root 3 over 2 I, and that's it. Easy. And then once we learn how to deal with any kind of even root of a complex with complex numbers, then you could look at any polynomial equation and solve it, no problem. But like when you think about other types of equations, like rational equations, well, that's not a fundamental operation. A rational equation, you just end up turning into some sort of polynomial equation to solve it anyway. So you could solve that just with no problem if an even root of a negative number comes up, just do what you know how to do. Then absolute value equations, that has nothing to do with with complex numbers like inherently. And contained within an absolute value equation is going to be like a linear equation or a radical equation. No problem there. So really all that's going to be left is just, okay, what if you had a logarithmic equation or an exponential equation? If we stopped at what trigonometry and algebra taught us, we don't know how to analyze situations that might involve complex numbers in those cases, but we're going to go ahead and learn all of that so that across the board you'll be comfortable with whatever's presented to you.